Many systems work well for a small audience, but once usage grows, the design decisions begin to change. Keep one example in mind: a cloud application whose users send requests to an API and read and write shared data. At small scale, that path can be wonderfully simple. The senior question is not, which impressive components can I add? It is, what evidence says the system needs another layer? For around 1,000 users, one application service and one database may be enough. A small system is easier to build, understand, operate, and change. Requests move calmly from users to the application and then to the database. There are fewer moving parts, so there are fewer places to lose time or introduce failure. That simplicity is not a temporary embarrassment. It is a design advantage, provided we know what it can and cannot absorb. User count is only a rough proxy. What matters is concurrency, request rate, read and write mix, data size, latency expectations, and how quickly usage is growing. 1,000 mostly idle users can be easier than 100 users uploading large files at the same time. Scale is a workload shape, not a vanity number. Before changing the architecture, measure the shape, traffic, saturation, queue depth, error rate, and tail latency. Those measurements tell us where to look next. As traffic rises, requests begin to accumulate. The application spends more time waiting, the database sees more concurrent work, and latency becomes visible to users. The constraint might be CPU, connections, storage I/O, a slow query, or the network path. Growth exposes bottlenecks. It does not tell us which one we have. That is why scaling by instinct is expensive. First identify the saturated resource, then change the smallest part of the design that addresses it. If the application is stateless, the first structural move is often horizontal scaling. Place a load balancer in front of multiple application instances. Requests now branch across healthy instances. Capacity grows, deployments can become safer, and one application process is no longer the entire service. This only works if state is externalized correctly, and health checks represent real readiness. More instances do not fix an application that shares unsafe local state, but the same traffic can still converge on one database. More application servers may simply deliver more work to the same bottleneck. Now the design conversation becomes about query efficiency, caching, read replicas, write paths, connection limits, and whether asynchronous work belongs behind a queue. Every layer solves a pressure point and creates a new operational responsibility. The goal is not maximum distribution. It is a system whose trade-offs we can operate. At larger scale, the architecture may grow into a layered system: edge delivery, load balancing, application services, cache, queue, workers, and a scalable data layer. The key is separation. Caches absorb repeated reads, queues absorb bursts, workers move slow tasks off the request path, and replicas improve read capacity. Observability connects the layers. Without latency, saturation, error, and queue signals, a distributed architecture is only a more complicated mystery. The goal is not to build a million-user architecture on day one. Premature distribution adds cost, coordination, and failure modes before the workload justifies them. Measure the workload, identify the bottleneck, change one layer, and measure again. That loop is more valuable than a fixed architecture diagram. Our example evolved because pressure appeared. First application capacity, then shared data, then burst handling and red scale. Each addition had a reason. 1,000 users may fit a simple application and database. 1 million users may need distributed capacity, specialized data paths, and stronger operational controls. The architecture should follow evidence, not guesswork. Start simple. Observe real usage, and expand only when the system shows where pressure lives. When your system grows, which measurement will tell you what to scale next, and what complexity are you deliberately choosing not to add yet?